not missing the forest for the trees here. So we have, in some area, we have macrophages that are sensing an infection in the tissue site. So say the skin, and there's a specific macrophage that I have located there. And it's going to start to trigger the release of cytokines, which is going to cause vasodilation, increased permeability, redness, heat, and swelling, all the things that you would get with classical signs of inflammation. And then inflammatory cells are going to migrate into the tissue, releasing inflammatory mediators that are going to cause even more pain. And this is a diagram here that just reiterates what we had been talking about recently. Here we have interleukin-1 and tumor necrosis factor alpha working together to induce blood vessels to become more permeable, enabling fluids to start to leak in, vasodilation as well. Interleukin-6, which is increasing metabolism, which is going to cause an increase in temperature in the infected tissue, but also going to help with healing and promote growth of new, like collagen or whatever you have damage there. CXCL8, which is a chemokine and a chemoattractant, it's going to guide neutrophils and macrophages to the infected site. And then interleukin-12, which activates natural killer cells, which is in turn going to make the natural killer cells produce cytokines that are going to keep macrophages on their toes and aggressive at the site of the infection. All right, so let's discuss all the types of cytokines. And for the purposes of this, I'm going to go ahead and put tumor necrosis factor and interleukin-1 beta together, because while they are structurally different and they have certain things that they do that are different, for the most part they kind of do the same thing. Tumor necrosis factor alpha. Some people call it tissue necrosis factor. I've heard it synonymous terms. Funny story about the guy who discovered tumor necrosis factor. He injected it in these mice that had horrible tumors. And he found that whenever he injected this compound into the mice that he had isolated from other parts, it completely obliterated the tumors. That's why it's called that, tumor necrosis factor. And you can imagine, he thought he probably cured cancer. He thought he was going to win a Nobel Prize. Everything, he had this anticipation here, and it turns out that doesn't work with humans. It doesn't do anything with us. It only plays a role in inflammation. So I feel so bad for that guy. But I mean, it wasn't all bad. It was used for controlling, a lot of pharmaceutical companies use it for controlling inflammatory diseases. Anyways, especially interleukin-1 beta, like we had previously talked about, this is in the inactive form. And then only then after, like we talked about with the inflammasome, does it become active. Both of these proteins, both interleukin-1 beta and tumor necrosis factor, are pyrogens, fire, generators, so they obviously cause redness, swelling, inflammation, things like that. And they're also, let me see if I can fit this in here, they're called acute phase proteins, which we haven't talked about yet. All right, acute phase proteins. Hopefully that will fit in there. We'll talk about each and every one of those later. But for both of these, they both have a local effect and they have a systemic effect. Now, the local effect of interleukin-1 beta and tissue necrosis factor, for really just for keeping it very broad here, is an increase. Sorry, I should have drawn that like an arrow. In the vascular permeability. By the way. The other thing that we have, and you can consider this localized because it is at the site of infection, where we have neutrophils being recruited. We'll talk about that in detail. Neutrophils go from the blood infection to the infected tissue. Okay, so those are the localized effects. Kind of hard to fit all this stuff in one place here. Obviously, it's a pyrogen, so it's going to have systemic effects of fever and things like that. But the only thing that I feel like systemically speaking that's important that you need to know is a decrease in blood pressure and edema. You have swelling all over, swelling especially at the tissue site. Okay, so that's how those work. Interleukin-1 beta and tumor necrosis factor, pretty much doing the exact same thing. They're pyrogens. They increase vascular permeability. They make neutrophils migrate from the blood to the site of infection. Because of this increased vascular permeability, we also have vasodilation, but we'll talk about that more as a systemic thing. which results in a decrease in blood pressure and swelling. All right, so the next one, we'll switch colors, is interleukin 6. And just like before, we have a systemic and we have a local effect. Systemic, local. I should have done those the other way. But anyways, so the localized effect of interleukin 6, I guess I should probably also mention up here that interleukin 6 as well is a primary acute phase protein. Primary acute, I'm just going to say APHPR, acute phase protein. This is a primary acute phase protein, whereas with these were secondary acute phase proteins. But anyways, interleukin is a primary acute phase protein, and it is also a pyrogen. Okay, so local effects of this is a increase in the metabolism of all the cells, really. My book makes the distinction of making sure that I say that the fat and the muscle cells, but it's also going to promote healing as well, so we're going to have increased metabolism everywhere. But more so in the localized areas. The systemic effects of this are also an increased metabolism, and it works by acting upon the hypothalamic thyroid axis, the T3, T4 thyroxine axis. I hope you can see that. But anyways, the systemic effects of this also would be an increase in our body temperature, and if it's high enough, it can cause fever. Fever. Hopefully you can see that. Fever. Being kind of messy, I know. The next one, I'm going to do it in gold if I can fit it in here. It is a cytokine. It's known as CXCL8. I prefer to use the term interleukin 8, but our book for some reason doesn't do that. The effects of this is, it's not really so much the systemic and local effects, so much as that it really is just a chemokine for neutrophils. Chemokine, I'm just going to say for phagocytes. It gets them out of the tissue with the help of tumor necrosis factor. It gets them out of the tissue, out of the blood, sorry, to the tissues at the sites of infection. And also notice that whereas interleukin 6 and interleukin 1 beta and tumor necrosis factor are both pyrogens, acute phase proteins, this is not a pyrogen and this is not an acute phase protein. Alright, so I'm running out of room here. Shoot. It's a cytokine. I'm drawing a big arrow here to say that it stops there and then it comes back here. Alright, so the next one is interleukin 12, which that diagram kind of talked about to a little lesser extent. And interleukin 12 causes increase in proliferation of natural killer cells. This increase in proliferation of natural killer cells is going to also cause them to express certain types of cytokines. And these are going to be cytokines that are going to activate or maintain activation of macrophages. A whole lot of things that we can talk about with natural killer cells. The only thing that we haven't mentioned, and I'm just going to start over here, and I'll do it in white, is it is a cytokine, is interferons, both type 1 and type 2. Remember, interferons interfere with viral replications. But that's not an inflammatory cytokine. They're not really involved in systemic effects, and they kind of have their own mechanism of action. We'll talk about interferons when we talk about natural killer cells and viral infections. But for the purpose of this, interleukin 1 beta, tumor necrosis factor alpha, these are both pyrogens, acute phase proteins that are involved in increasing the vascular permeability, which gets neutrophils to the site of the infection. We have interleukin 6, which is involved in increasing metabolism, and then we have CXCL8, which is a chemokine for phagocytosis. It's going to get neutrophils, guide them to the site of the infection. And then interleukin 12, which is involved in basically just activating macrophages, but also keeping up a supply of natural killer cells to keep the macrophages in check.